Okay, great. Hi, everyone. Thank you for your time. And I'm pleased to be talking to us this afternoon about a social constructivist understanding of technology transfer in project-based settings. And as Jennifer mentioned, I have been looking at the broader theme under which my research falls is technology in the built environment. Yes, I'll talk you through the research background and then the problem at hand that was examined, and then move on to briefly touch on some shortcomings in relevant past studies about the subject of project-based international technology transfer, and then talk you through the meat of the presentation, which is about the sociotechnical perspective and the theoretical lens that was adopted for this piece of research. That's the social construction of technology, and talk you through the findings and what that means for the management of projects and future research. What you see on the screen is any guesses? A Ford Model T, probably, yeah, the credit has given it away. A Ford Model T, you can see it in the left in its shining glory as a complete technical artifact sitting, perhaps useful for a ride around the city. But on the right, you'd see the same Model T converted into a farm equipment, a piece of farm equipment actually for plowing. And you can see that the rear wheels have been transformed into something else, but the frame is the same. The person using it is different. That's a farmer. And there are actually two people using it, and they are using it for a completely different purpose. When you look at this, it gives you a hint about, well, it should draw your attention to what we should be thinking about as technology, or what comprises technology when we think of the word technology. Is it just about the artifact, or it is a constellation of other things leading to a desired outcome? The same artifact, but different forms of functions based on the context. On the left, you find it in the city, but then on the right, this is from the Henry Ford Museum, and it's from rural America around the 1920s. So in terms of background, technology gaps between developed and developing countries have been existing for a long, they've been existing for a very long time. And these gaps are reflected in many areas, including the delivery of built infrastructure assets. These include buildings, stadia, highways, dams, bridges, you name it. And as a result of this technology gap, we see key infrastructure projects being continuously developed by foreign firms. And this sustains this gap and perpetuates a reliance on by developing countries on construction firms from advanced countries or countries with advanced economies. And you can see on the slide here, a $200 million African Union headquarters project, which was completed in Ethiopia by the China State Construction Company, and then a 76 million euro interchange in Ghana, which was executed by a Spanish construction firm and actually designed by a consultancy from Spain as well. And so there is this vicious cycle of technology gaps that are continually sustained by the existence of the gaps to begin with, the fact that the delivery of key infrastructure is often by foreign construction firms, and that feeds into an unhealthy dependence of foreign firms and consequently depletes or even removes the potential of creating local capacity to deliver such key projects in developing countries. It has been the goal of the United Nations through its technology wing to try and bridge this technology gap through what is called international technology transfer. The idea or the assumption underpinning it is that countries and firms with more expertise in the delivery of specific kinds of projects, whether it's infrastructure projects or building projects, they would be able to use their advanced technology in developing countries, and through the process of delivering the project and by working with local construction firms, they would transfer technology to the construction firms in developing countries, and over again try and bridge that gap between the countries in the global north and then developing countries in the global south. This was widely embraced in the 1980s into the 90s and remains to date. There are examples of World Bank projects and also projects by other multilateral firms and also multinational corporations that have been trialed in countries including Europe, including Egypt, and Egypt, Rwanda, Uganda, Tanzania, and Ghana, all in a bid to try and bridge technology gaps. Most of them have been construction and manufacturing based, including the construction of factories, rail, oil and gas pipeline projects, as well as housing. But then over the 50 years that international technology transfer has been attempted to try and bridge this technology gap, the gap still remains, and there's evidence in the literature to support it. Singapore tried, in terms of project-based international technology transfer attempts, Singapore in the late 80s and 90s delivered their rail network using international technology transfer as their approach. This involved bringing in foreign construction firms to work with selected numbers of general contractors who were which were owned by Singaporeans, to help them obtain the technical expertise, as well as also obtain the physical technological artifacts that would help them deliver such kinds of projects, that is the real projects. It saw some positive outcomes to an extent, as reported by Fori and other literature. And in Algeria as well, they also attempted, they attempted a similar path in the delivery of a factory for manufacturing electrical components. The interesting thing is, at the end of the day, the foreign contractor delivered the project. It was managed by a foreign firm for some time, but after they left, it ended up like the tractor you see in the bushes over there, rotting away. The factory ended up having to wind down. In South Africa, oil and gas pipeline projects have also been delivered used as a vehicle to try and transfer technology to the local construction firms to be able to deliver projects of such scale or similarity. But it is reported that the outcomes have been underwhelming and the reliance on foreign firms persists. And so the problem at the moment, well, the problem that has been identified is that for over 50 years, international technology transfer attempts have been tried, but the technology gaps that they are meant to tackle persist. And when we look at the academic literature, that is in practice, but when we turn to look at the academic literature, there appears to be a simplistic assumption about how the process of transfer looks like, technology itself, the actors involved, and the environment within which technology transfer takes place. And so the question then that becomes apparent is, shall we turn back and look at what happens in a project-based international technology transfer attempt? Because in order to better understand how to bridge the gap, the technology gap, it is important to take a critical look at exactly what happens by putting aside all these simplistic assumptions. How can we better understand? And you see as you can see, the symbol in the bottom left corner is an Desigr symbol. It's actually of Ghanaian origin, an Desigr symbol, which means let's return to the basics. Let's return to the starting point. Let's return to what matters or what's important. And so that informs the thinking behind the research question that is posed to understand what happens in a project-based international technology transfer attempt. Taking a cursory look at existing literature, I've initially mentioned that there are simplistic views about the process of technology transfer. Even in project settings, most of the literature buy into a linear thinking about the process of technology transfer, which involves starting from a fixed point, that is starting from a foreign firm and the technology moving or being handed over to a recipient organization, mostly in a developing country. Alongside this view, technology is often viewed as stabilized and fixed, and the actors are categorized often as being recipients or takers. And so further to that, most of the conceptualization around what technology is that it's a fixed and stable, identifiable object. And often technology is often compartmentalized into explicit technology, that's the tangible bit, and then the intangible bit that has got to do with human skills, expertise, and understanding. And another assumption is that technology barely changes over time. What is passed on is what remains in the given country. And also a shortcoming in the literature is that contextual influence on the form and function of technology is barely, the contextual influence is barely considered in examining international technology transfer. Further to the conceptualizations, more often than not, actors from foreign countries are deemed as those who are given the technology, and those in the receiving countries, in developing countries, are often seen as those who are receiving. And because of this tagging, there is a stream of literature that also talks about the fact that there is then reticence on the part of those who are tagged as givers to think that once they are giving and there is no knowledge about the potential for them to receive, there is that reluctance to actually follow through international technology transfer projects and actually enable the local counterparts to obtain the foreign technology that they brought in. It's either it's going to be half done, or they are going to be very protectionist about it, because once the assumption is they are giving out the technology, then they are eroding part of their competitive advantage to be able to come back to these developing countries and deliver the projects that they have been reliant on them for over the years. This rigid categorization is prevalent in the literature, and there's the assumption that they have got fixed roles and interests based on which side of the aisle they sit, whether as transferers or transferees, givers or recipients. And their influences on shaping the form and function of technology are barely accounted for in a lot of studies. Okay. Sorry. And all back to the environment within which international technology transfer takes place. It's more often than not seen is mostly discussed as an extraneous element that is just a shell within which all the processes about technology transfer takes place, and it only exerts limited influence on the processes that take place as part of transferring technologies using projects as vehicles. But then if you turn away from that, so these are the shortcomings that I've highlighted. If we take a turn away from that and take a broader view of what could potentially be happening in technology transfer in project settings, a sociotechnical perspective offers a lot in that regard. And the sociotechnical perspective essentially does not separate social elements and when I mention social, I mean non-technical elements. That includes actors, national, international, and local regulations, standards, processes, existing structures, and institutionalized settings or institutionalized components or elements, such as ways of thinking and going about project execution. These fall under the non-technical elements. And on the other side, we have the obvious technical components that are that define the physical elements of a technology. But the sociotechnical perspective does not distinguish between the two. Rather, it brings the two together in order to offer a comprehensive understanding of how the social and the technical elements in any innovation attempt or technological initiative come together to lead to a desired outcome. This is embedded in constructivist traditions, which essentially go to say that there is nothing that can be taken out of a picture in order to have a complete image of what is happening at any given point in time. So it is not helpful, essentially, to segregate the world into a fixed mode that frames an understanding of what happens in any given project. It rejects technological determinism that has long characterized understandings about technological innovations, and with emphasis on project-based international technology transfer. And by technological determinism, the assumption, what is meant is the assumption that anything essentially the assumption is technology is the solution to all problems that can be identified. If you have a technological solution, that is the end of that problem. It does not take any fixed view about what technology is, and that is what is the agnostic view of technology. And a sociotechnical perspective also offers a network approach for analyzing the interactions between actors, technology, and the wider context in a given location. Examples include the social construction of technology approach, actor network theory, and large technological systems view of innovations. So moving on, within the sociotechnical perspective, if we take, if we further zoom in on the sociotechnical perspective, there are key fundamental assumptions about what technology is. Essentially, technology comprises emerges from the interaction between technical artifacts, social elements in dynamic or ever-changing contexts. And so this heterogeneous composition of actors and technical artifacts within a given setting, the interpretation here is that they are in constant flux, they are constantly changing. And so what you can identify as technology today might change if you come back and look at it in 2 years or a month or 3 days. This is very ideal this is a very idealistic explanation of how the sociotechnical perspective operates. And we'll see more about how that plays out in the research that I will explain later. So, in contrast to the pervasive views that I have already touched on from the literature, a sociotechnical view of project-based international technology transfer brings into focus the dynamism of project environments, the complex human, technical, and context interactions, and wider context influences, and also helps us focus on the heterogeneous nature of the networks out of which technology emerges. Projects, as we would understand to varying degrees, comprise multiple actors, brings together a wide range of technical artifacts, as well as technological knowledge and insight, all within boundaries of regulations, standards, laws, and also interacting with client interests and battling site as well as wider context constraints in delivering a given outcome. So this highlights one of the dynamics in project environments that have often been under-examined in the literature. And this has, the neglect of this complexity has fueled the persistence of the linear view of thinking about international technology transfer. But that is not the case, as we would, as the sociotechnical view reveals. So guiding this, the research that was undertaken is the social construction of technology lens. When some social scientists were a bit fed up with technological deterministic views and also technological optimism bias. This seminal idea was based on the study of a bicycle as a technological configuration. The main goal of the proponents, that's Pinch and Biker, is that if they are able to show the complexity behind something as simple as a bicycle, which most people in Cambridge are very acquainted with, then if they are able to demonstrate the complexity entailed in it, then they are going to be successful at demonstrating that more complex technological configurations have more intricate dynamics behind them. To do this, they set out to examine a bicycle by looking at its various parts over a period of time. They examined historical data to come up with this theoretical way of thinking about how technology emerges in a place, has a specific identity that is linked to the place from which it was developed and the place where it's going to be used, as well as shaped by the actors involved in its development and use. Guiding this theoretical lens are some key assumptions, which mainly border around technology. First, technology has an interpretative flexibility, and this means that actors can alter the form and function of technology by ascribing different interpretations to its technical artifacts. The second is that technology is socially constructed. Anything you think about as technology is socially constructed. If you think back to the Ford Model T that I showed, it was developed first in the US. It was developed to meet a market, to deliver to the market an automobile, but then the different actors, those living in the cities used it for commute, those living in the countryside used it only for their weekend travels, and those living on farms or having farms used it for a wide range of purposes, as we saw in the first slide. And so by technology being socially constructed, it means it's not permanently fixed. and will undergo changes to suit where it is being used. And the fact that it has interpretative flexibility and is socially constructed suggests that it emerges from a dynamic heterogeneous network comprising actors, technical artifacts, and situated within a context. The key constructs guiding this theoretical lens for looking at how technology evolves in a given place can be grouped into four. We've got relevant social groups, and these are relevant social groups are people who are shaping the form and function of technology, and they share in sets of views or ideas about the given technology in question. Relevant social groups, a key point to note is that relevant social groups are not categorized based on pre-existing professional, organizational, or national backgrounds, but rather the extent to which they coalesce around a given interpretation of technology or a given view of technology is what helps them to be categorized. So you could have in one relevant social group, you could have a university professor, you could have a construction worker, you could have a bus driver, you could have a nurse, all sharing in the view that a particular piece of technology holds benefits to improve health-related choices. Another group could ultimately, comprising an entirely different group of people, could hold the view that technology, a health-related app, holds the potential to be used to individual or private health conditions. So that then brings us to the technological frames. These are the sets of interpretations that are ascribed to technology, and it is artifact specific. It's not applicable to all components of a technology. As part of the processes of technology undergoing shaping and evolution, various relevant social groups tend to identify problems about technology, and different actors are also entitled to proffer solutions that may be adopted and roped into the shaping of the form and function of technology, or may be neglected. The extent to which an actor's suggestions or recommendations may be taken into consideration vary, and they've got a lot of factors underlying it. Solutions simply are the steps taken to remedy problems that are identified. However, it is useful to note that what may be a solution to one relevant social group might be a problem, might lead to the creation of a problem for another social group. Closure and stabilization linked to the gradual process by which technology or a technological network becomes stabilized or gradually becomes firm or firmed up. So closure is achieved through the elimination of problems surrounding a technical artifact, and stabilization emerges from an increasing perception among relevant social groups that a technological configuration needs no further modification. And the extent to which a group can determine stabilization is shaped by their influence, the constellation of actors forming that relevant social group, and their influence in the overall shaping process. It is also useful to remember that closure could happen in two main ways. It could be rhetorical closure or closure by problem redefinition, depending on who is leading who is an influential actor in shaping the technological evolution process. There could be actors who would influence decision-making by responding to questions or problems by either deflecting it by, in this way, turning the attention of the problem from the main point by highlighting a rather important aspect of the technology or the technical artifact in question. Closure by rhetoric is simply the lead actors responding to any query by saying that that problem is not a problem, and that it is, for instance, that problem is not a problem. For instance, part of the campaign linked to the evolution of a bicycle was that when the rubber tire was developed, people came up with concerns that it was risky to ride on a muddy path, but then it was essentially, and also another version of the bicycle that was developed was deemed too dangerous, particular. But then part of the manufacturer's response was merely rhetoric by coming out with an advert that simply said, it is safe to ride a bicycle. And by this, they simply went by the rhetoric approach, and by problem redefinition, when the problem of the tire was raised, they rather pointed their attention to the fact that having the rubber tires, as opposed to steel, riding on steel frames, allowed you to get to your destination faster. In utilizing the SCOT approach, that's the social construction of technology approach, one has to examine, in using the social construction of technology approach to examine the evolution of technology in a given context, constructing SCOT diagrams is very important, because it is by examining the journey of each technical artifact that one comes to an understanding of what has happened to the technology to begin with, and also how the technology has evolved from the start up to the point where the study concludes. And so you can see from the key that the focus in using SCOT is identifying the artifact in question, looking at the technological frame surrounding the identification of a problem, the solution that was proffered in response to a problem, and the actors buying into a given technological frame. So for the project that I'll talk about, these diagrams were constructed for 3 groups of technical artifacts of the technology that was studied. So moving on to the empirical part of the research, the case study was an examination of the evolution of the monolithic formwork technology. This was designed in Portugal, manufactured in Germany, and brought to Ghana. The components were brought to Ghana. They comprise several elements, including panels, as you would see in the bottom, in the image on the right, panels for windows. There were components that were for locking, and also there were components that were for staircases and floor slabs, as well as walls. This was brought into Ghana to be used on a public mass housing project, which was expected to produce over 5,000 housing units, but later revised downward to about 1,400 housing units at the price of $200 million US. It was a government led project with funding from other foreign bodies. The contractor who delivered this project was Brazilian. The consultants were Portuguese, and there were some local Ghanaian consultants, that's the public sector consultants for infrastructure project delivery, working on behalf of the government. They oversaw the delivery of this project. Gathering data on this project was mainly qualitative. This included gathering over 525 project documents, conducting over 35 interviews, and you can see me on the site going for several site visits. They are now analyzing this volume of data. The volume of data collected was mainly driven by the construction of the SCOT diagrams and complemented by thematic and content analysis using NVivo qualitative data analysis software. In summary, this is how it looks like a bit of a mess, but it tells a rich story. What we can see here in summary is that technology transfer in project settings is not as simple as has been thought to look like. And what even comprises technology is not just the technical artifacts. Rather, technology as we see it, the monolithic formwork technology as we see it, what you can call monolithic formwork technology is not just the artifacts, the panels and bolts and connectors. Rather, it emerges from a network of actors, the artifacts, and the delivery of the building projects themselves. And you can see two images here. The first one with the linkages and the second one with the linkages to illustrate how all these components, the three main components of actors, the project deliverable outcome, and the technical artifacts themselves are in a constant process of change, leading to the desired outcome, that is the construction of the buildings. And I make emphasis by pointing to how wider context factors in the green dotted lines shape the project-specific context, and these in turn shape what happens in the delivery of the project. Going into the detail of the findings, the study showed that the process of transfer, as thought of, is not linear at all. It consists a myriad of socio-technical interactions, and these socio-technical interactions can be broken down into the evolution of the technology itself, changes among actors, and changes in wider context influences. In terms of the technology, the monolithic formwork technology that was designed in Portugal, manufactured in Germany, and shipped to Ghana for this project, the components themselves did not constitute technology. Rather, it emerged from this heterogeneous network. And interestingly, the monolithic formwork technology evolved 3 times, significantly evolved 3 times. The initial set that was brought to Ghana was trialed on the project, and a number of faults were identified. A number of faults with the technical artifacts. Some parts could not fit properly. A number of faults in terms of the process of delivery, because the local workers could not get their heads around how to incorporate particularly the stairs, the components for constructing the stairs. And so all the components of the monolithic formwork technology that were brought to Ghana for the purpose of the stairs were completely taken out because the local actors were not at the point where they could utilize it effectively. And another interesting point is that the foreign contractor themselves could not teach them how to utilize these components, and so they had to take it out. At the end of the day, what emerged was a hybrid version between what was imported and the wooden elements, the local way of constructing staircases. And so at the end of the day, the monolithic formwork had the complete section of stairs taken out. The third wave of change was had to do with fixing some panels in the monolithic formwork technology. Some parts led to bulging outer leaves of the buildings because they they were buckling. They were not stiffened enough, and so were buckling under the weight of wet concrete. These had to be redesigned, and their connections had to be redesigned midway in the project. And so from that point onward, the configuration of the parts that were used were changed because the connections were changed to make them tighter, and the panels themselves were redesigned to make their midsections stiffer. At the end of the day, the localized version that was used is not what was initially designed. And that brings into question what then is the idea of transfer of technology, if we are to think of it in opposition to the linear way that I have earlier highlighted. The actors, interestingly, were not confined to the binary groupings of I'm working for the foreign firm, and so I am a transferer, and you are the local Ghanaian, and so you are merely receiving it. All the actors at various points in time were intricately involved in shaping how this monolithic format technology was designed and the function it performed. In the initial project stages where they were thinking about the design of the monolithic format technology or the components, you had most of the influence was from foreign actors who were at that point engaged in thinking about the project. When these components were manufactured and brought onto site, then because they were now in the hands of the local players or the local construction workers, they could then identify some shortcomings about these technical artifacts based on which they had to be redesigned. I've already mentioned the issues about the connectors. Another way which they completely changed, which the involvement of the actors changed the function of the technology, of the monolithic format technology, can be seen in how the local actors came up with a strategy to have a model house complete with all the panels in place and the components as well as the struts in place. And then they spray labeled them numerically to help them arrange the configurations for each building or for each floor faster. This was as opposed to the original idea of having one worker who was going to read the shop design or the shop plan for how each of the panels had to be arranged or configured on site. The local workers realized this was not going to work for us, and so our best approach of dealing with this in order to deliver the buildings as fast as possible is to spray paint each of the panels so that immediately we move them from ground floor to the first floor, we know where each component has to go. Changes in the actors significantly also impacted how the monolithic formwork was used. At a point in time on the project, there were pressures for the project to speed up, but because the technology had been introduced into a new context and the foreign workers were themselves struggling to adapt it into the local environment, the project progress was very slow. And so a number of the foreign workers were removed and replaced by those who were deemed more experienced in the use of similar technologies elsewhere on the continent. So the changes in these actors led to a rethink of how the components were going to be used and how the project teams erecting the buildings were going to be configured around the use of this monolithic formwork technology. And in terms of the environment, moving beyond the process of transfer, the technology and the actors, the environment within which the project took place, or within which the international technology transfer attempts took place, had a profound influence on all the socio-technical developments that were observed. And it was in itself not detached, but rather deeply woven into all the interactions. First and foremost, these are highlights of how the environment shaped the entire choice of technology, how it was used, and how this led to specific outcomes on the housing project. Because there was an election, the government wanted a very quick turnaround on the project, and so they were looking out for a form of technology that was going to help them build fast. And this monolithic form of technology is what was then proposed and rapidly embraced by the then government. That didn't work out pretty well because at the end of the day, there were several delays and the project was not delivered in time. The design of the buildings as well as the monolithic former components were shaped by international and local design standards, and as well as building regulations, local building regulations. Moving from this wider or broader environment or broader context to the project context, project hierarchies also influence the extent to which actors could be involved in the shaping process, as I explained earlier about the local and foreign actors and their influences. A more vertical project hierarchy, which was adopted in the beginning, meant that only very few actors could influence the shaping of the monolithic form of technology and how it was going to be used. But after the foreign staff were replaced, they adopted a more decentralized approach to delivering the project, which meant that many people could then access and therefore contribute to the shaping of the process. Over the course of the technology's evolution, there was constant reference to specific components such as local building regulations and laws and design standards that were used to back up explanations for why certain changes had to be made to this technology. So what from all these findings that we have found, that we came up with from the study of how this technology evolved in this particular project settings? In terms of the management of international technology transfer projects, there is the need to think of a more adaptive way of managing such projects by turning away from rigid project management principles that support more vertical structures for project delivery, and also taking a turn to embracing a less exclusionary approach to decision making in order to get many actors involved as soon as possible. And this is important because it will quicken the time needed to adapt to new contexts when new technology is moved to a given place. In terms of research, this study goes to show that technocentric studies are ill-equipped to unpack all these complexities that were brought to light from adopting a socio-technical or a social constructivist view to the study of technology. And it raises questions about the veracity of the concept of technology transfer in itself. If you look at how technology evolves, depending on the nature of actors involved and contextual elements, the question is, what then exactly is being transferred? If you'd like a more detailed read about what I've just talked about, you can scan the QR code and enjoy your reading. Thank you very much for listening.